All right, line W1, learning task number 5. We're taking a look at AC soft starter operation. What we have to remember about an AC soft starter operation is that it is a form of reduced voltage starting for a 3-phase standard motor that we are going to go and have. Which means that if we're going to be doing a reduced voltage, it's giving us reduced current, which means that we're going to be looking at a reduced amount of torque. So we do not necessarily have a lot of torque when we're starting out. Just because we're ramping up the voltage slowly does not mean that the speed is necessarily going to be ramping up slowly as well. The motor can kind of be stalling and then it can pick up all of a sudden once we hit a certain breakpoint inside the speed that allows that to go into operate. It is also going to be establishing voltages by averaging a length of time. So it's averaging voltage based on time. Is how it establishes it. And really it's just going to be based upon the firing angle that we are going to go and have for each of those SCRs. This is not rectification, okay? We've looked at rectification, we looked at DC converters, we've looked at, taking AC and converting into DC in order to run stuff. We are not doing that with these. Well, all we are doing with these is we are going to go and pass the AC through, we're going to match it, but we are going to go and chop away part of it as it's going through. The way that we're doing that is once again through our SCR. We're going to go and use the SCRs as we normally do. It's going to be a standard SCR that we will have, which means that we need to go and gate it into conduction. That's going to give me my conduction. And then the, that's a conduction, that's wrong, conduction. And then to go and shut it off, all I need to do is drop below my holding current, my IH, that we should be quite familiar with at this point. The way that we drop below holding current is commutation, right? Once we drop down, we hit that zero axis, we're going to drop below holding current. And if I've got another one operating in the opposite direction, once again, I'm going to go and drop below holding current or commutate right over there. Because we want to pass the entire AC sine wave through, we are going to go and have these two operated in inverse parallel. Every single line that goes through a soft start needs to go and have SCRs that are going to be operated in inverse parallel coming off of here. So that anytime that I have got my waveform coming in like this, where I've got a positive, I'm going to go and have my two SCRs. I take a look, I say which one of these is positive right now, or which one would be able to pass a positive, and I see that SCR1 would be able to go and pass a positive through at this point. So SCR1 is going to go and carry the top half of the waveform. That waveform, I can go and choose to gate it now, whenever I want along there, and that SCR will go and pass that positive waveform through. Then it hits this point where it's going to go and shut off SCR1, and then I'm going to go and start building magnitude of voltage in the negative direction. When I do that, now I can go and fire this one on, because we see that that one's got the cathode facing out. Therefore, this is going to be the one that will pass the negative on that line. So I'm going to be able to do the same thing. I could choose when I'm going to go and gate these to go and pass that negative through. And so basically, these two are just going to go and take turns. Every time there's a positive pulse, this guy is going to go and fire. Every time there's a negative pulse, this guy is going to go and fire. And I just choose how far in I want to go and fire each one of these. If I fire these things really, really early, in other words, if I've got a firing angle that is going to be, 0 degrees from my firing angle, then I'm going to be able to pass the entire waveform through. That would be this thing fully gated. Now, this is not where we start. This drawing is a little bit backwards in that way. It's not that we're not used to having some, wobbles or errors inside of our materials. It's just, it makes more sense if we start looking at it right over here. Because what is the soft start designed to go and do? It's designed to go and ramp up our voltage and then operate at full voltage, and then we can go and ramp back down again on the way out with this thing. So what we're going to do is initially, when we're starting up the motor, we are going to go and have a really, really large firing angle like this over here. Because I've got that large firing angle, I'm only got a small conduction angle, and so then I'm only going to go and get a small amount of voltage. If you were to go and take all of this and average it out, I've got values of 0 volts all the way across here, and then I've got a value that's high here, and then it's chopping down lower, so I can really kind of chop that peak off, flip that one down into there, and then average that with all of this, and I would see that the overall averaging of a waveform about that size is going to end up being something like that. So really, what my load sees, my motor in this case, is it sees the same effect as if I had a sine wave that was only that tall, just a tiny little baby sine wave over there. Which means that if it's only got a tiny little baby sine wave, it's only going to have a tiny little baby current. and therefore we don't have a lot of our inrush that's going to go and happen inside of here. So during startup, late gate it, this is starting over here, I'm going to gate everything late. So I'm going to start building a small amount of voltage, which is going to build a small amount of current. We're going to start getting a little bit of rotation. And then what I'm going to do is I'm going to start changing the gating. I'm going to go and have a smaller firing angle. Remember, firing angle is the part that we're missing. So I'm going to have a smaller firing angle. Once again, if I were to take a look at this, I could take, these halves over here, over top of this half over here. I could average this whole thing down, and I would see that the whole thing would average out to become a slightly higher value of voltage that I'm going to go and have. Right? We had this one here, which averaged out to become very low. Go back to that starting one. Averaged out to become a very low value of voltage in both the positive and negative. This one averages to become a bit higher. I then continue, as I'm going through my startup, I go to this one where now I'm going to be gating this thing once again a little bit earlier on, and I'm going to be seeing as a result a higher value of voltage overall. And then I take it all the way over to here where I'm going to be at full value of voltage, and at that point I could go and take the SCR offline. And when it comes to my shutdown, I'm going to do the same thing. I'm just going to go and ramp it down by going and chopping away a little bit of this waveform at a time. It's not going to be long. We're going to go and do this all over top, like maybe 30 seconds or something like that. But it is going to go and allow us to get the effect of having a small amount of voltage that is just slowly going to go and build as we go across there until we get to full voltage and we are running. It does not change the speed of the motor because you should be familiar with the fact that speed and frequencies and poles are all going to go and be related, right? Our frequency is still going to be the same. It's just a small magnitude of voltage, so it's going to be the same speed, but it's going to be starting at a low voltage with a low current and raising up. These things, soft starts, do not change speed. They just change inrush. It is a reduced voltage method of starting a motor. Once again, if your motor would not start across the line initially, it will not start with a soft start as well, because it's not developing any extra torque out of here. It is just going and slowly bringing in a motor that we do have on the system when necessary. Last thing that I want to talk about is just these where you can get sometimes specialized control modes that are going to go and give a kick at the very beginning. Where basically, if I were to go and take a look at it, I'm going to have at the instant that I start up, because if I start super, super low, sometimes that motor won't start rotating at all, right? With these small averaging values of voltage that are coming up here. And so what we sometimes do is we just give it a little bit of a kick, but a short enough kick, it's not going to disturb the system. So some of these will actually go and have a short flash where it's going to go and start with a low gate it, and it's going to go whoop, and then take that thing back. But it's going to do it over top of like just a half second or something like that, just to give it a little flash and a little bit of a kick to start up with, and then it drops it right back down to this value, and then it slowly ramps it up the way that it normally does. It is programmable. It's not the default state to go and start like that, but it is programmable in there. If you're having trouble getting your motor started with a soft start, most of these are going to go and have the ability to do that. All right, that is it for our soft starts. We are going to go and proceed on to variable frequency drives next. Once again, do not mix soft starts and variable frequency drives. The soft start only changes the inrush. That's all that it's designed to do. It does not change the speed of the motor. It changes the inrush and the torque. The variable frequency drive is going to go and change the inrush, the speed, and the torque all together. Okay, let's finish this one up and head on to the next.